recording. So we'll jump right into things here. Um, what I'm going to do is I'm going to go through the practice test that I made available to all of you guys. And so you can, whoops, what did I just click? Okay, good. Things are still here. Um, so what I'm going to do is talk you through this and you can take notes. You guys should have this. I emailed it to you on Monday with the answer sheet. And of course, the answers are right on here. But I'm going to kind of walk you through this. So I'm going to turn off my video so that I can uh, plug in my um, scratch pad here so I can actually draw here on this thing here. So um, this is what you're looking at right here is the practice test, like I mentioned, that I had sent to you guys. Okay. And let's see here if yep, I can draw. All right. Um, so if you pay attention tonight and it all makes sense to you, you're ready to roll, which means you could go take the final exam when we're done tonight. Hopefully be done here in about a half hour or so. And thank you, by the way, Olivia, I appreciate that. Um, and you will be just in great shape. Um, so anyway, you might consider just doing it tonight, just so you're all finished. You have till the end of the day tomorrow to finish up everything and get it to me. So, all right, let's jump into things. Making sure my pen's working. Using figure one, um, 5,500 grams equals how many kilograms? Okay, so first thing I'm going to model for you is make sure you're looking at the right figure. And there is on your test, there are 2 pages of figures, which, um, let's see, if I choose this and scroll down, I can scroll to that maybe if it's on this version of it. Let's see here. Um, no, it's not. Okay. It's something that I sent you guys, but there are some charts. Okay. All right. So what we're going to do is it's basically you're going to follow the following procedures. In your notes, I taught you a couple of weeks ago that when we're doing this thing called conversions, okay, when I'm converting anything to something else, I gave you a kind of my chart system, and I said, look, here's the system, here's the rule that when you're converting a smaller number, because if you looked at the chart, okay, it says that 1 kilogram on that chart, figure 2, is 1,000 grams, okay? And they're giving me grams here. They're giving me this many grams. So this is the smaller item. I'm saying this smaller because if it takes 1,000 of those grams to make one of these, obviously the one on the left is the smaller one, okay? I'm keeping all of my grams, the smaller things, all on the left-hand side of my chart, and all of what I'm converting into, my kilograms, on the right side of the chart. And the rule is smaller, when you're going from smaller to larger, you always divide. That's the rule, okay? And I like to think of it this way. When you're making something, I look at that first word of conversions, I'm making something from smaller to larger. Anytime you're making something smaller, you're dividing it up, okay? So what you do is you look at the chart, and it's saying that 5,500 grams, these are my grams, okay, equals how many kilograms? That's what it just said right up here in the question, okay? All right. If the chart says 1,000 grams is 1 kilogram, okay, my rule is that I'm supposed to divide. So look at my chart. If you're just looking at my chart and you're going, teacher, how do I figure out what I'm supposed to divide? I kind of get that I'm supposed to divide when I'm going from smaller to larger, and I'll get to look at my notes while I take the exam and everything. How do I know what I'm supposed to divide? By the process of elimination. You're not dividing this because you don't know what that is. You're not dividing 1 because that doesn't change anything when you divide anything by 1. So if I divide 5,500 by 1,000, I get 5.5. It goes into it 5.5 times. So I've got all my kilograms on the same side of the chart, And that is my answer, okay, 5.5 kilograms. All right, I'm going to go through number 2 a little bit faster here, but it's using figure 1, convert 17 meters to centimeters, okay? So meters to centimeters. And when I look at a centimeter is like 1/100th of a meter, and so it's smaller, okay? So I'm converting the larger, okay, the meters, this is the larger, okay, to the smaller, to centimeters. This is my smaller item. So the rule is when you're going from larger to smaller, I look at that first word there and I think in my head, wait a minute, larger, I'm making something larger. What do? The rule is you multiply. That's my rule, I'm multiplying. So I look up at the chart and it says that 1 meter equals 100 centimeters. All right, I filled out my chart. Now, what do I do? I'm trying to figure out what to do next here, okay? I'm looking at, okay, the rule is to multiply. I'm not multiplying this, and I'm not multiplying this. What's left on my chart? And I would multiply that, that's 17 times 100, okay, and get 1,700. All right. Let me clear my screen here and clear all drawings. Go up here to number 3 here. Raise this up. And again, you guys have this, I emailed this test to you, okay? So everything you're looking at on the screen, you have. If there are exactly 2.54 centimeters in, so this is centimeters, and this is in 1 inch, okay? There's 2.5 of these in every 1 inch. So over here on my kind of chart here, I wrote 1 inch and 2.5 centimeters, okay? This is my centimeters over here. So I made a ratio. Remember, 2 numbers compared to each other is a ratio. 4 numbers is what they call a proportion, or something's proportional. So how many inches are there in 5 centimeters? Okay, so I've got my centimeters. These are my centimeters down here, my C-E-N-T, centimeters. And they say you have 5 centimeters, C-E-N-T, okay. They want to know how many inches, okay. So I set up, that's my X inches. This is the question they're asking, how many inches? So they gave me, in the question, they gave me this. And they're asking for this. They want to know how many of those, okay? So I have now set up a proportion. One ratio next equals another ratio. And I taught you guys a couple of weeks ago, excuse me, that you can cross multiply. If you cross multiply there, what you can do is, if I cross multiply 2.54 times X, okay, that gives me this right here, okay? And then 1 times 5 is 5, that gives me that there. And in this class, we learned that, hey, if I want to get X by itself, if I divide to get X by itself, if I divide both sides by 2.54, okay? 2.54 on the side.
I'm muted, it's fine, but just like, I know, I'm just trying to.
Actually, you're not muted. If you want to go ahead and mute yourself, that'd be great. Thank you.
I want a cheese stick.
Okay.
Yeah.
Looks like the teacher's going to have to help mute you.
This is what you signed up for when you got a girlfriend, Kevin.
Hey, mute all. Yes, mute all. There we go. Sorry, folks. Back at it. Here we go. Where was I here? Am I looking at the right thing here? Yeah. Okay. Let's see here. So anyway, we created a ratio there. And then from that, we were able to calculate what X equals. Okay. So I cross multiply 2.54 times this X here. Okay. Cross multiply these, and then if I divide both sides by 2.54, because I want to get X by itself, what that does is that that eliminates that. So I got to divide the other side by 2.554, and that gives me 1.968. Okay. Now, I want to show you something. The actual question asks us to the nearest hundredth. Answer it to the nearest hundredth. So I go over to my answer, and this number right here, 6, is in the hundredth place. So 1.9 is in the 10th place, 6 is in the hundredth, 8 is in the thousandth. Because the number to the right of it is 5 or more, that's how we got 1.97 inches. If you're wondering, how did that get to 97? It's because we're rounding to the hundredth place. Okay. All right. I'm just going to kind of talk you through number 4 and then skip 5 because they're the same kind of thing. But using figure 2, this means you'll look at your second diagram on your test, and you will have the way I put it set up in Canvas. It's right there. You can look at it right there by the question. You can see it. Okay. By what percent did the home prices in King County increase from 2000 to 2005? Okay. So you'll look at a chart, and you'll have, you know, like your years and stuff, and you'll see home prices going up in price in the year 2000 and the year 2005. Okay. Okay. And you're going to see prices of homes going up in the thousands. Okay. All right. Let me show you how to do this. This is how you calculate percent change. Okay. And I taught you guys this a few weeks ago. You start with your ending value. Okay. Ending value minus the starting value. So you might want to write this down, okay, if you forgot it. You take that and you divide the answer by your start value. That is the formula for calculating percent change, okay? So you can add this to your notes for percent change. I'm trying to find out by what percent did something change, okay? There's your formula right there. You can put this on your notes to just kind of walk you through this. It is ending value minus the starting value. Take that answer and divide it by the starting value, and you'll get a decimal. So on your chart, which I'm not showing you right now, but the ending value in the year 2005, I'm going to draw a little arrow here, was houses were $450,000, the average house, $450,000, okay? The starting value in the year 2000, the average homes in King County were $300,000. So I had the ending value minus the starting value, and that gives you, when I do this, these two things, that gives me this right here, 150,000, okay? Then the formula says take that answer and then divide it by the starting value. The starting value, again, was right there. That's 300,000. That was my start value. Okay. So that gives you on a calculator, your calculator is going to say something like that, 0.5, you know, might just say that, or 0, 0, or something like that. Move the decimal point 2 places, and you've got a 50% increase in value. So that's the same formula that you're going to do for this one, and you'll have one more like it on the test. Actually, maybe 2 more like it on the test. But the key here, guys, is for you to remember, oops, sorry a second. Let me grab my mouse here. There we go. If you can remember this formula, you can figure out a bunch of these kind of problems, okay? If you remember this formula right here, you're gonna be able to figure out like 3 of the test questions right here. Ending value minus the starting value. Take that answer and divide it by the starting value. That gives you a decimal. Convert that decimal into a percent, and you are good to go to the next question, okay? All right, let me scroll down and let me erase my screen again. And so question number 5 on the practice sheet is the same thing. It's you're working with percents, okay? So, but they're going to have you kind of forecast in the future based upon what you looked at. So, so if there's a 50%, you might want to write this down in your notes here. I think I'll add this little point here just to make sure it's really clear here. If something goes up by 50%, okay, if you just looked in from 2000, let's say the year 2000 to 2005, there was a 50% increase in value, okay? And they want to know if it went 50% up. What's going on with this pen here? Okay. If from that 5 years it went up 50%, okay, you might want to write this in your notes here. And it's asking you for 2010, from 2005 to 2010. What we can guess is that, okay, if in 5 years, if I write this down here, this is 5 years. Okay, this time period here, right here is 5 years. If that 5 years it went up 50%, then from 2005 to 2010, it's probably going to be another 50% increase that it's going to go up. So we can kind of extrapolate that. If in the first 5 years it went up 50%, the next 5 years it'll go up 50%. All right. Here's how that relates to what you see on the screen here. If it was $450,000 for a home in, say, the year 2000, okay, or 2005. If it's going up 50% in this 5-year time period, that's point as a decimal. 50% is 0.50 as a decimal. If I multiply 0.50 times the cost of the house in 2005, I'll get a number, okay? And that number is like 275 or something like that. If I add that number to the cost of the house in 2005, that will give me the cost of a house in 2010. This here is a 50%. You're calculating in this little parentheses here, a 50% increase, okay? Now, if you're really smart, okay, you would multiply it like this. It'd be faster. You wouldn't have to get a number, then add it to 450. You could do like 450,000 times 1.50. And that would give you the answer. That would give you your 675,000, because that's 150%. Okay. Okay, number 6, same thing. Okay, it's calculating percent change. So I'm gonna move on from that one just for the sake of your time this evening. Number 7 is the same exact thing. You got 110 clients, it moves up to 150 clients. They want to know what percent. They want to know to the nearest tenth. Same thing. You're using that calculating percent change. Number 8 is the same thing, but I'm going to stop there just for a moment, just to just kind of make sure it's really clear. What you're going to be given, okay, is everything right here on your test, okay? And so what they're going to want to know is, what's the percent of weight lost? All right, so here's what happens, and I know this is a little bit, this is the start here. I can see it's out of order here, but it'll probably look better on the test. And this is the end. So these two, Oliver and Jamie, are trying to lose weight. Oliver starts at 280 pounds, ends after their, let's see, if their first month, he weighs 244 pounds, okay? So if I subtract 280 minus 244, I get 36 pounds. This is how many pounds he lost right here. He lost 36, okay? If I divide 36 by 280, I'm going to get 0.129, which moves the decimal point to a 12.9% weight loss. He lost 12.9% of his body weight, okay? Likewise, Jamie, started at 190 pounds. A month later, it weighs 175 pounds. If I subtract these two, she lost 15 pounds. If I divide the 15 pounds she lost by her original weight, which is 190, that will give me a decimal, which I convert to percent by moving the decimal 2 places to the right. Okay. All right. Okay, I'm going to move on to the next one, which is identify the factors. Okay, the factors in the following equation, and you guys will remember in my lessons and in the book homework and my videos and stuff. An equation has the word equal in it. Okay, and equation has something equal, like something equals something else. That's called an equation. That's why it has the equal sign. All right. Factors are things like in the number 6, the factors of 6 are 1 and 6 and 3 and 2. Those are the numbers that multiply into 6. When we talk about numbers and variables like -7 and y, because they're right next to each other, they're multiplied. Okay, they are multiplied because they're right next to each other. These two things are multiplied and these two things are multiplied. Okay, again, I will say why, because they're right next to each other. Okay, things that are, if I say 6 and in parentheses 8, that means times. Okay, 6 times 8. So the factors, again, it wants to know these factors are -7. That's why I'll just write it underneath here. That's a factor because it's something multiplied by something else. That's what factors are. Y is a factor. Notice how I'm putting commas here. Okay, they're separate. They're each separate factors. 3 is a factor. And y, the other y, is a factor. Now, technically, somebody could say, but aren't there 2 y's? So isn't there really just -7y and 3? Technically, that's correct because y is a factor here. But if you listed all of them like this, this is fine. You're showing me you know what a factor is in an equation that has variables. Okay, so again, factors means multiplied. If you put this in your notes here, factors means things multiplied next to each other. Okay, I'm going to move right along here. See, hopefully this will work. Yes, it's working. All right. All right, the next one here. Identify the expressions in the following equation. Okay, and again, I have what they're asking for is expressions. And in my notes to you in my lecture, I said those are kind of like a phrase. Okay, in English, they're part of a sentence. Okay, if I compared it in English sentence, but they're not the full sentence. Likewise, in algebra, expressions are like half the equation. What's on half the equation? Okay, so that's an expression, and that's an expression. 3y plus 4. Okay. So over my answer here, that's why it looks like this. I've got 7y plus 2. That's an expression. It's the thing on the 1/2 of the equal sign. And the other one is this one right here. Okay, so again, expressions are the part of the equation that's on 1/2 of the equal sign. All right, scrolling down here to the next problem below. Okay, it says to identify the polynomials, what type of polynomials. And we talked about polynomials being these things like 7x squared plus y. They are terms separated by plus or minus, okay? And I taught you there are the 3 most common types of poly, which means many terms. Polynomials are a monomial, which is this one right here, because it has one term. Okay, you guys have this in your notes. A binomial, which has 2 terms. And then, of course, a trinomial, which has 1, 2, and 3. And technically, I should have drawn a box like this, -3, because it's part that minus is in front of it. 3 terms, okay? So those are the 3 kinds of most common kinds of polynomials, and they match with their word, okay? Number 12 says types of reasoning, and we kind of went through this quickly. There's like one question like this on the test, just so you know, there's not going to be a bunch, but when we generalize and move from the specific cases to a general rule, here's what is the process called? It's called inductive reasoning. And if you want to like draw this little picture here, okay, it's like we got specific details on the ground, like a scientist sees all these things happening at this lake, okay, all these dead animals and frogs that have warped looking strange looking legs, and fish that are dead, and birds start dying around it. So the scientist is looking at all these details at this pond, and it's going to go up from the specific, it's going to generalize up to start making general conclusions, you know, from the specific up to a generalized idea that there must be some form of pollution or something affecting this pond. So when we start with the little details, okay, we generalize from move from the specific. We're moving from the specific, okay, that's these little details, to the general, okay, this is the general idea here. They call that inductive reasoning, okay. Conversely, which means the opposite of that, is if I move from a general point, a conclusion or a theory, and I move down, D, like D for down, okay, that's deductive reasoning. And you start with a general idea or hypothesis, and from that you move down to the specific little details and try to figure those out from that general idea. All right, that's that kind of reasoning. I'm going to move on, and here we go. All right, 13, consider the sequence, -15, 12, -9, -6. What is the formula? Okay, what's our formula here for figuring out the nth term? And again, guys, I'll pick another color just for variety here. They want to know the formula, okay? All right. So in your notes a week ago, I taught you last week when we went through chapter 14 and 15, that the kind of sequence, when we look at our sequence here, this is term number 1 here, okay? We talked about this is term number 2, etc. We went through this, that these are terms in a sequence. Let's look at how they change. We started at -15, so on a number line, okay, if this was 0, it's way back here, -15. Then we moved to -12, which means it's actually getting bigger. It's -12. Then we got -9. Okay. Then we got -6. Okay. 5, 4, 3, 2, 1. All right. What is happening here? We can look at this sequence and just think about it logically. It changed from 15 to 12. That's 3, 15, 14, 13, 12. It got 3 bigger. It moved towards the right, 3. From 12 to 9, that's 3. From 9 to 6, that's 3. I'm adding 3 each time. And it's consistent. It's 3 each time. Okay, in that sequence. All right. So we looked at the formula for what we called an arithmetic sequence, okay? And you have this in your notes where you're adding the same number each time is. This is the formula. You'll have this in your notes. You start with your starting value plus or minus, because it depends on how you want to look at this. Sometimes you can add a negative number to something and it's getting smaller, and then in parentheses, the term we're trying to find out, which term we're trying to, that's the n value, okay? And again, the term is like term 1, term 2, term 3, term 4. this is the formula, minus, okay, 1 is n, whatever term we're looking for, minus 1 times, okay, what is our consistent adder, okay? Each time we're adding 3, okay? So that is the formula. Whatever we're adding each time, that becomes the number on the outside. That's our formula. And so that's why you see this over here, okay? The starting value in my sequence is negative 15. That's my starting value. Plus, I'm adding each time, whatever term I'm trying to find out, okay, we haven't asked for a term yet, n minus 1 times what I'm adding each time, which is 3. And that's how I got this formula over here. Okay. So a couple things to watch out for. These are kind of keys, okay? Because I know you're probably thinking, how am I going to remember all that? How am I going to remember which kind of sequence this is? Here is what I've taught you, is that when you look at a sequence, see right here, this is a sequence of numbers in a row. If I'm adding the same thing each time to the previous number, that's a key term, to the previous number, because that's going to come up here in a few minutes, okay? If I'm adding the same number to it each time, that's what we're going to be calling a linear or arithmetic sequence. But for this test, all you're going to have to know is that it's a linear sequence. It's in a line. Linear means adding the same number each time. And the key there is linear means adding, okay? So you might want to add that to your notes. When I see a sequence of numbers and I'm adding the same thing each time, that is a linear sequence, okay? And there it is. There's your formula. You can copy this down as long as you remember that this 3 here is the number you're adding each time, okay? I'll give you another example. If I had the sequence 2, 4, 6, 8, 10, you can see I'm adding 2 each time. So that number would be 2. That would be the number right here, okay, in that sequence. All right. Using the nth terms in question 13, it says, what is the value of the 12th term? Okay. So it wants to know in this sequence, if I go back up to my sequence here, number 13, this is term 1, 2, 3, 4. It wants to know what would be the 12th term. Okay. We're going to plug it into our formula. Going to come down here to my formula. Starting value, negative 15. That's my first term. Look up at the sequence here. Negative 15 is the start value. Plus n, this n right here, okay? This is the n right here. In this case, it said the 12th term. That's the n. That's the term they want. So that's where we get this 12 right here. Okay. Then the formula says n minus 1, which you see that right here. Here's my minus 1 here, times, what is the number we're adding each time? 3. Okay. Well, 12 minus 1 is 11, times 3 is 33. Negative 15, which is my start value, minus 15, plus 33 gives me 18. Here's what it means. The 12th term would be 18. Okay. So again, kind of key concepts on this little slide right here. Key concepts. When you look at a sequence of numbers, if you're adding the same thing to it each time, that's going to be an arithmetic or, and for the sake of the test, a linear sequence. And this is the formula for it. Okay. All right. I'm going to clear everything right there and move down to my next slide here. All right, speaking of sequences, folks, there we go. I'm getting close here. So I've got to identify the following sequence as either arithmetic sequence, okay, or geometric, or neither. Okay, so they want to know. Arithmetic is like, just so you know, this is like linear, okay? It's the same idea. It's the same thing. And geometric is like what we're going to also be calling exponential growth, where we're multiplying. But they want you to look at the sequence here, 5, 10, 20, 40, and ask yourself, is that arithmetic, which is where you're adding the same number each time? Or is it geometric? Geometric means you're multiplying. So if you want to add this to your notes, that's what geometric means, is I'm multiplying the same thing each time, same number times the previous term. All right, let's look at our sequence. I got 5, 10, 20, 40. This is how my brain would look at this. I'd go, in my mind, I'd think, okay, 5, how did it get to 10? I must have added 5. Okay, let's try adding 5 to the 10 here. 10 plus 5 is 15. Oh, I got something different. So right away in my brain, I go, wait, and then 5 from 20 would be 25. This is not adding the same number each time. So in my brain, I go, it's not linear, okay? It's not an arithmetic sequence, okay? Because it's changing by more than just adding the same number each time. So then I start thinking about the 5. How did the 5 get to 10? Well, 5 times 2 is 10. Well, then let me try multiplying 10 times 2. And what does that give me? 20. Let me multiply that 20 times 2. I get 40. Oh, it's pretty consistent. I'm multiplying the same number 2 times each previous term. So that means it is geometric. And that's why your answer over here is geometric, because geometric growth is multiplied growth, multiplied by the previous term. Linear and arithmetic growth is added growth, added to the previous term. All right, that brings us down to the next question here. If we look at 16, in the following table, compute the y value. Compute means find that's the same as find, okay? If that helps you with the vocabulary, to compute means to find the y value for a given x value by multiplying the x value by 3. So just to kind of clarify what they're talking about when they talk about x and y values here, okay? All of the ones here on the left are the x values. They're in that row, okay? All of the ones on the right, these are the y values. These are all y values. Okay. So given all that, it says, so they're going to give you all the x values, and they'll give you the first y value. It says, find the y value by for a given x value by multiplying the x value, multiply the x value by 3. All right, let's look at the first row. X value is 0 here. 0 times 3 equals 0. Okay, that gives you 0. Let's do the same thing with the next one. 1, that's my x value, times 3 gives me 3. X value 2 times 3 gives me 6. Okay, do you get the idea here? So we're multiplying the x's times 3. All right. And then let's see if I have to scroll down here. Well, in the following, look at 17 here. In number 17, it says to take, if I can, just 1 second here, fix this. There we go. In the following table, compute the y value by multiplying each previous y by 4. Now, I want you to pay very close attention to what it's asking. It wants you to find, okay, I said this compute means to find the y value by multiplying the previous y. Notice here, we're multiplying the previous y, not the previous x value, like it said in number 16, by 4. All right. So now we're focused really on just doing stuff to the y values. It's all it asks us to do in the directions. It said multiply, find all these y values by multiplying the previous y by 4. Well, 1 times 4 is 4. 4 is now the next y value. 4 times 4 is 16. 16 times 4 is 64, etc. Okay, that's how we got that kind of growth. All right. All we're doing here on this test question, guys, is following the directions. It's maybe in some ways easier than it seems. Read the directions real carefully and just do what it asks you to do. All right. Then once you get that, the next question or so is going to ask you, okay, first of all, what type of growth is number 16? Okay. Well, teacher just said linear growth is where you're adding the same number each time to the previous value. So if I change into a bright colored color here, let's look at my chart here on the left. 16. 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 3 is 9. Oh, I'm looking at the sequence. We're adding 3 each time, and it's consistent. It's the same change each time. This is linear growth. Okay. That's the type of growth it is, which the next question is going to ask me. That's why, because it's in a line. If I charted it on a graph with my X and my Y's, it would look like a line, okay? 3, 6, 9, it's changing the same each time. Let's look at the other side. What type of growth is this? Because like questions 18 and 19 are going to ask that. Well, I'm going to start with my first value here, my 1. How did 1 get to 4? 1 times 4 is 4, okay? But I might be thinking, well, I added 3. So 1 plus 3 is 4. Well, 4 plus 3 is 7. Uh-oh, how did I get from 4 to 16? I didn't add 3 that time. 16, 17, 18, 19. No, that's crazy. That's not adding. Nothing's being added there. Something's going on there. That's a lot more. It's not consistent. So I asked myself, I'm not adding. So what's my other option? Multiplying. And so I asked myself, well, 1 times 4 is 4. Okay, I must have multiplied this by 4 to get to 4. 4 times 4 is 16. Oh, 16 times 4 is this. I am multiplying by 4 each time. Okay, that's what I'm doing, is I'm multiplying. That's the principle. I mean, that is the sequence that's going on, is the previous y value, like it says, the y value is being multiplied by 4 each time. And the teacher says that when you're multiplying, that's geometric growth, okay? That is the type of growth it is geometric. And so that's how, when they ask you on the next question, what type of growth that is, okay? All right. Now, additionally, the next question is going to ask you, like, to give a formula, okay? And so I'm going to kind of erase all this, give you a couple more seconds if you're copying this. Okay, and I'll scroll down. So questions 18 says, using the question 60%, write the function of the model and the data, whether a function is linear or exponential. We already answered the linear exponential growth thing. It's exponential if it's multiplying also, okay? In the first one, it asks us to take, we can find the y by we multiply 3 times the x value. Now, let me show you what I mean by that. I'm going to scroll back up, okay? Look at the thing, look at the actual question here. It says this, if I pick my pen again, okay? Find the y value for each given x value by multiplying, it says the x value, okay? It's not the previous y value, but the x value by 3, okay? So we can say that y equals, in this chart right here, if I want to find the y, it equals, take the x and multiply it by 3, okay? Or 3x would be another way to write it. Now, I know that somebody's listening going, hey, teacher, didn't you just tell us that it's exponential and geometric growth if we're multiplying? Listen to really carefully what I'm saying. And what I said earlier is, when you are adding the same number to these y values, to the previous value you got, that's linear growth, okay? But in this particular question, it asks you to multiply times the previous x value, okay? So this is like the term. This is, in a sense, like the term. Or if these were years here, this would be year 1 and this would be year 2. Okay. And so it's a little bit different because we're multiplying not by our previous term. Remember, in a sequence, like this is a sequence right here, you were multiplying the previous term by 4. This is, they're multiplying it by the x value. So I know that's a little bit confusing, but what they really ask you to do is find the y by multiplying the x times by 3. And so we just said y equals 3x, okay? So that's where this y equals 3x came from, is we just literally wrote out a formula for what they told us to do, okay? Now, number 17, y equals, okay? And what do? We do, one way to write is 4 to the x, okay? Which means 4, whatever term it is here to the second term, that'd be my x, my exponent, or the third term or the fourth term, that would be my exponent. So that's my exponential formula. Is, remember an exponential formula last week we talked about, we have an exponent, okay, like squared or cubed. So each time we're taking 4 and to whatever term that is, that's what my exponent is. Okay, I'm going to move on for the sake of time here. And again, a couple of pieces of advice. You'll have your notes. You'll have everything you want. You can, it's like an open book test, so you can use your notes. Just do your own work, please. And you should be just fine on this. All right. The next one is just a matter of calculating percentages. Okay, so let's take a look at the question. It says a company has 1,200 clients and wants to gain 15 more clients each year. So here's what we're starting with, and they want to gain 15% each year, or each quarter, excuse me. Use your calculator to compute the table around your values to the nearest whole number. All right. So here's how you would do this on my calculator. They're going to give you all of these ones that are bold will not be there. You're just going to give a 0, 1, quarter 1, 2, 3, 4, 5, and you'll be starting with 1,200 clients. All right. They say we're supposed to gain 15% every year. If you take the easiest way to do that, I'm going to show you a shortcut, is go to 1,200 on your calculator times 1.15. And that's going to give you a decimal, or that's going to give you an amount. Okay. You know what? No, don't do it that way. Do it like this. Well, you can do it. There's 2 ways to do it, but the normal way that most people, I learned how to do it, is I would multiply it by 0.15. Okay. I would multiply that times 1,200. And then I would take that answer and I would add it to the 1,200 to get 1,380. Okay. Because you're finding out what 15% of 1,200 is, and then you're adding it because that's the growth. Okay. But the shortcut, like I was mentioning a moment ago, the shortcut would be to go 1,200 times, well, what is 115%? It'd be 1.15. Okay. That will give you, if you punch that into your calculator, that should give you 1,380. Then you could take this 1,380, this new answer, multiply it times 1.15, and that's going to give you 1,587. Take 1,587 times 1.15, etc. You guys get the idea? So you'll be able to figure out all the way down through the 5th quarter how much money, how many clients they're going to have. Okay. And again, it says to round your values to the nearest whole number. So whole number, it'd be, if I had 2.4, that would round to just 2. Okay. If I had 2.5, that would round up to 3, because this is a whole number. The 4 is a decimal. All right. That's how you would do number 19. Okay. All right. You're just figuring out 15% of each new number and making sure you add it correctly. All right, last question, and I'm going to let you guys ask any questions after I turn off my recorder here, and then we'll move on to letting you guys out of here, okay? All right, number 20, last question of the evening says, the function, and we learned last week that a function is the formula, okay? If that helps you think of it more clearly. The function that models the data for question 19 is T, okay, that's the total number of clients, equals starting value 1200 times, this is what I just showed you, 1.15, to the Q, and that Q there is what quarter it is. Okay, that they're giving you the formula in this question to use. Using this formula function, how many quarters will it take to surpass the company's goal of 4,500 clients? Okay. Well, what you can do is, you can kind of use that formula and go, okay, well, let's say that it took the ninth quarter, let's say it was the ninth quarter. And if you remember on your calculator, I told you that you have a little square root, like x squared symbol on your calculator. And right above that, you've got a little symbol, the key right above it. And that is where you can put to the ninth, like 1.15, press that number to the ninth, and you can do exponents that way, okay? So remember that on your calculator. But if you tried it to the ninth, you would get 4,221 clients, okay? So that's after 9 quarters. This is quarter 9 here. And you could start, with 5 and work your way up. Say, oh, I got to get to 4,500. How many quarters is it going to take? Well, if I tried 9 to the ninth quarter, okay, and I got this much, which is not enough, okay, what's the next one is 10. If I use the formula 1,200 times, this is 115%, all right, 15% gain, to the 10th quarter, this is my quarter here again, that gives me 4,855. Look at what it's asking for. Oh, that's enough. That is more than the 4,500 they want. So it would take me 10 quarters, okay? And that's why my answer over here is 10 quarters, because that quarter is the exponent that I'm using here. And the nice thing about question 20 and the nice thing about your last question on exam 3 is it will give you this formula, okay? It might be different numbers, but it's going to all be spelled out for you, and it will give you the actual formula to use. So what I'm going to do is I'm going to turn off my recording.